Hello everyone, we're going to start today's lesson like we did yesterday with 3 ACT practice problems. So you definitely want to get out a sheet of paper. If you have graph paper, you are allowed to use a calculator on ACT practice problems because you're obviously allowed to use a calculator on ACT test. So go ahead and pause the video, give this problem a try, and then resume playing. All right, so if you need more time, just pause the video again. So what could be very helpful here is actually graphing this. Now, you don't have to actually use graph paper. We could just get an idea, a sketch. So if we're looking at the inequality x is less than or equal to 2, this is going to be a vertical line, solid vertical line through 2 on the x-axis. And we're going to be shading everything to the left. So I'll shade that here in a little bit. Now for the second inequality, this just becomes in slope-intercept form. Y is greater than or equal to negative x plus 4. So we'll go ahead and graph that. Y-intercept of 4. And I have a slope of negative 1. So this is also another solid line. So the question is, what is the least value that y could have? So if we were to shade here, I know I'm shading to the left of the red line, and then I'm going to shade above the green line. So it's kind of asking for the ordered pairs. Out of all the ordered pairs, what is the lowest y value we could have? So if we're looking at the y values going along the y-axis here, obviously 10 is at the top. We know our ordered pairs are definitely lower. So if we go down to the very bottom right here, this point is included. So this is at the y value of what? This is our lowest y value, which would be right over here at 2. So that's probably the easiest way graphically to be able to identify this. All right, let's look at another one. All right, pause the video again. Go ahead and read this over and see what you think. All right, again, if you need more time, go ahead and pause the video. Just to point out, these are brackets here around the 5 and the 3. But I just want to read this one over because I want to pull some pieces from this. So Valley High School and Mountain High School have decided that selected students will attend a daytime theatrical performance that costs $5 for each teacher and $3 for each student. 1 teacher and 10 students from Valley High will attend, and 2 teachers and 25 students from Mountain High will attend. Which of the following matrix products represents the ticket cost in dollars for each high school? Now, we never did a problem quite like this in class where we had to just come up with two matrices that had to be multiplied together. But if we go through and see which ones, just put the problem aside, which ones maybe we can't even multiply. Like what's wrong? Maybe they have incorrect dimensions in order to multiply. Can we rule any out? And if you took a look at D and E, we have a 2 by 1 matrix and then a 2 by 2. So D and E are out because if I go across my row here, I only have one number, and if I go down the column, so I cannot multiply D and E together. So that kind of narrows it down, so maybe we can make a little bit more sense out of this. If we did try multiplying the matrices together, if I go to the first one, I'd multiply this row by this column. So this is telling me I've got the 5 represents the $5 for each teacher, and then the 3 is the dollar amount for each student. So here, if it's saying $5 and I have 1 teacher and 10 students from Valley High, so I would have $5 times the 1 teacher plus $3 times the 10 students. So does that make sense? I would have 5, let me write that in blue. I would have $5 times the 1 teacher plus $3 times the 10 students. And then from the Mountain High School, we would have $5 times 2 teachers plus $3 times 25 students. And is that what that says up here? Yes. So A is the correct answer, but let's take a look at B and C. So for B, I'd have to multiply $5 times the 1 teacher, but then $3 times the 25 students, but those are from 2 different schools. So that's what's wrong with B. And then for C, we would have $5 times the one teacher plus $3 times the two teachers. So that's what's wrong. So it is matching. When I go to multiply this together, it is matching the two sentences as we multiply the row times the column for the paragraph that's here. All right, let's take a look at one more. Again, pause the video to read this over. If you need more time, pause it again. But in this problem, the table below shows the number of rows and columns in each of 5 matrices, A through E. For distinct values of K, M, and N, which of the following matrix products is not possible? So the best way to do this is just to go through and write out the dimensions. So if we needed to multiply E times D, so let's write out the dimensions of E. It's always rows by columns. So E would be an N by M matrix. And then D would be an M by K matrix. So would we be able to multiply matrix E? E has to go first. Times D? Yes, because these two middle numbers match. Next, let's take a look at D times C. I'll write this out wider here, but D has to go first. So D is an M times K, and C is what? K times N. So we would be able to multiply those two together because the inside numbers match. Let's take a look at C times E. So C is K by N, and E is N by M. So would we be able to multiply those together? Yes, the ends match. Let's do A times E. So A is M by N, and E is N by M. So again, those match. So it has to be K, but let's see here. Let's multiply A times C. So A is M by N, and C is K by N. So no, these do not match, which means we would not be able to multiply those together. So K is the correct answer. All right, let's go ahead and take a look at the answers to yesterday's worksheet 1 through 14. Oh, I'm sorry, I forgot. I had one more. I thought I only chose 3 today. Go ahead, and all you're doing is multiplying these two matrices together. Notice they're all possible answers, so undefined is not an option. Again, if you need more time, pause the video. But let's just take a look here. Here we have a 2 by 2 matrix. Here we have a 2 by 1. So our answer matrix, the two middle numbers match, so we're good. Our answer matrix, so we're looking for a 2 by 1 here. So we could rule out A, B, and C, because those are all 2 by 2s. So let's go ahead and carefully multiply these. Again, if you need more time, pause the video. Again, we want the row by the column. So first we're going to have 2 times 2, which is 4, plus we have a -5 times -1, so we have a 5. Now really, all we have to do is get, as long as we're doing this correctly, if you notice E, that's going to give us a 9, so it should be E, but let's finish this. Next we have our second row times our only column here, so we're going to get a -6 plus a -4, and that's going to give us our -10. So E is the correct answer. Now let's go ahead and take a look at the homework. So I'm going to go over a couple of these. Now 216, I know I said in the process of yesterday's lesson that you can divide 216 by 2 or 3, but in this case those weren't really helping. 216 is actually 36 times 6. So sometimes we just have to keep trying numbers. So what this would turn into is 36 times 6 times V. So the 36 comes out as that 6, and the 6V is still stuck underneath. What was nice is we see 216 again in number 5. Yesterday in class we did some examples with the 512. So remember, 512 is always 256 times 2. And the square root of 256 is 16. So again, once we see these numbers keep popping up, we know they're always going to be factored the same way. And just to point out, number 10, 100 is a perfect square, so there's no need to factor that. Number 7, it's always hidden though, but 80 is 4 times 20, but 20 still has another 4 in it, so it's actually 16 times 5, and then we would have p squared times p. So I'd circle the 16, so that would come out as a 4. Circle the p squared, so that'll come out as a p, and what's left underneath is 5p. Number 12, 64, we would just leave it again because 64 is a perfect square. And take a look at the rest. So as you're checking your answers, just write down any that you have questions over, email me, and let me know if you have any questions or you want me to go over any others with you. We're going to practice some more today. So just these 3. If you want to pause the video and give them a try, go ahead. What's a little bit different here is now they have numbers out in front of them, so it just changes things a little bit. Let's take a look at number 1. I'm going to leave the 3 out there, and then we just go about our business the same way that we were doing yesterday. So how could we factor 75? You had one of the homework problems had the 75 here. If you were thinking 25 times 3, you are correct. X squared I'm going to leave alone because it's an even power, and then y cubed becomes y squared times y. So I'm going to circle the 25, circle x squared, circle y squared. So the 3 stays out here. Everything that comes out just joins it. So it's really going to become 3 times square root of 25 is 5. Then I have an x and a y that also comes out. And what's left underneath is 3y. So I only have this extra step now, multiplying the 3 times the 5. So we get 15xy radical 3y. So if you weren't sure how to do these, and now that we did number 1 together, you can pause the video again and try 2 and 3. All right, now for number 2, 384 is a rather large number, so it's going to be a little time consuming here, but let's go through the division process. So if I divided 384 by 2, we know it's even, so 2 goes into 3 once, so we'll have a 2 here, subtract. 2 goes into 18, so bring down the 8. 2 goes into 18 9 times, so that goes evenly, and I would just bring down the 4 now. So it's 192, but that's not helping. So 192 is not a perfect square. Let's divide 384 by 3. 3 goes into 3 once, so bring down the 3. We just get a 0 here, bring down the 8. 3 goes into 8 twice, so we'll get a 6. And then 3 goes into 24 8 times. Now, 128 doesn't help because it's not a perfect square, but one thing I want you to know about 128 is it is 64 times 2. So since 64 can go into 128, 64 can go into 384. And here's another way. So I would just keep going, though. 384, we could divide it by 4 if you want as well. So 4 doesn't go into 3, but 4 goes into 38 9 times. It's actually 36. We subtract, bring down the 4. So 4 goes into 24 6 times. That doesn't help. Now I'm not going to try 5 because it doesn't end in a 5. Hopefully we can get this in the next round here. So if I have 384 and I divide it by 6. Now 6 goes into 38 just 6 times because that's 36. If I subtract, there's a 2, bring down the 4, 6 goes into 24. So there's my 64. Or if I go back up to the top, if I said 384 was 3 times 128, and then I factor the 28 into 64 times 2, here's my 64 times 2 times 3, so there's my 6. So we eventually got there. It did take a little bit of work. We have to have that sometimes. So I'm still going to leave the negative 6 out in front. The 384 we're going to factor into 64 times 6, and then m to the 4th times m. So now I'm going to circle the 64 and m to the 4th. So I'm going to get a negative 6, still stays on the outside. Square root of 64 is 8. Square root of m to the 4th is m squared. What's left underneath? A 6m. Now just multiply negative 6 times 8, so we get a negative 48m squared times the square root or radical 6m. So sometimes we do get larger numbers. All right, number 3 should look a lot easier. Still leave the 2 out in front. Now we have 81. So hopefully if you recognize it, it is a perfect square, so I'm just going to leave it be. Just 81 here. Then I'm going to factor the variables if necessary. So the x's are necessary. X squared times x. The other 2 I'm going to leave alone because they're to the even powers. So what am I going to circle here? The 81, the x squared, y squared, z to the 4th. 2 stays on the outside for now. What else comes out to join it? Square root of 81 is 9. Square root of x squared is x. Square root of y squared is y. Square root of z to the 4th is z squared. What's the only thing left underneath? The lonely x here. So just multiplying the 2 times 9, we get 18x, y, z squared, and then the square root of x. All right, so yesterday I just posted the front side of the worksheet. Today you're going to have to finish the back, so 15 through 30. That will be, you'll have to submit that by tomorrow. As always, guys, take care, and let me know if you have any questions.